Okay, so we have been doing congruency. So far congruency has been something like matching length, matching angle. So what is similarity? Similarity, it can be similar triangle, it can be similar figure, it can be a lot of similar things. If I want to tell you about similarity, I think it's easier if you think about, there's ice cream cone. Like there's a Magnum ice cream cone. Then the ice cream cone can be the mini one or the bigger one. Okay, I don't know whether y'all know or not. Okay, so there's the usual size of ice cream cone. Okay, and there's also like a miniature, like a mini cone. So this kind is called similar. Okay, so there's also another kind of similarity in real life. I also don't know whether y'all know or not. So it's something like, bottle of perfume. Okay, so some perfume are something like this. So there is a full-size perfume. So there is also a miniature size. So this idea is called similar figure. Okay, so in real life, we see like miniature of certain thing, right? So this is the concept of similarity. Okay, so ice cream cone, there are the full-size cone, and we also got mini cone. So if you have not seen the mini cone, I think next time you go to supermarket, you take a look. There are mini cone or the bigger cone. Okay, so what are the features of similar figure? So we are very good with congruent figure already. Congruent figure, we just match everything. So if you look at similar figure, right, they should have the same shape. So can you see, like just now I try to give you an example of cone. So if this is a cone, the mini version is also a cone. So in similar figure, you are dealing with a bigger version and a smaller version. So, but both has to be same shape. Okay, so because you are dealing with something bigger and something smaller, so of course, right, their length are different. Their length are different. So very simple. If you look back at the cone, the smaller one is shorter compared with the bigger one. So, and of course, the diameter of the cone is also different. So because we are dealing with a bigger size and a smaller size, it will come in different length. And there must be in a fixed ratio. It must be in a fixed ratio. Then we will consider it similar. Okay, so what do we mean by same ratio? So for example, this is 1 unit, this is 3 units. The diameter will also be in the same ratio, 1 unit, 3 unit. Okay, so this is the idea of ratio. So later on, we talk about that. So this is the most important idea. So we will not be matching length and similarity. So I would like you all to pay attention. You have been matching length because there's congruency. So when it comes to similarity, right, we will not be matching length. Instead, it will be same ratio. Okay, so that's the critical basic idea. And then, of course, we got different size because there will be a big version and a small version. Okay, and what about the angles, right? The angles will still be the same. So the tiny angle here, for example, it will still be the same. So if I want to summarize for all of you, right? In similar figures, we got length ratio. But you still can match the angle. So in contrast to congruency. So in congruency, we match length and we match angle. So you will need to have the distinction between these two. So these are the overlying overall picture. So congruency, we keep matching length and angle. So most of you find it very simple. Similar figure, you cannot be matching length. You must tell yourself you no longer match length because you're dealing with a bigger version and a smaller version. So it doesn't make sense that you are matching length already. Okay, but you are still able to match angle. So in both congruency and similarity, you are both able to match angles. Okay, I think if I'm going to get you to look at example one. I'm sorry, the example one, I think I chose a very bad figure, bad diagram, because they look almost the same size, right? But in fact, one of them is smaller than the other one. Okay, so I know it looks almost the same, but they are not supposed to. Okay, so how do we know that they are not supposed to? Because the question say that they are similar. So if you are worried that you could get confused, right? Maybe you would like to tell yourself is you got to write out the ratio, but you can still match the angle. Okay, so that is the part. I'm going to teach you how to write the ratio. In congruency, I teach you how to write, how to match a length, correct? So I'm going to teach you how to match a ratio. The ratio, right, will be done in a fraction format. Okay, so let's not talk about answering the question first. We will just focus on matching first. Okay, so my habit is I'm going to stack the alphabets. So if I stack the alphabet, the matching of the angle will be easy. The matching is like how you match in congruency. So there shouldn't be any difference. So where is the ratio? Okay, I would like you to do the ratio in fraction because it will help you to calculate. Okay, so first ratio will be here. So PQ over XY. So this is called ratio. PQ over XY. Can you see I circle up? Then I also have QR over YZ. So that's how I do my ratio. So I would like you all to have these habits, build these habits of writing ratio. Then I will have PR over XZ. And these three ratios are supposed to be equal. So the first thing is you write out the ratio. Then we will try to answer the question subsequently. Okay, so now I write out the ratio already. Okay, I can also be looking for, okay, let's try to answer the question now. So if you look at finding the values of A, do you realize A is angle X? So A is angle X, so I should match with P. So this is also A. Then Z is angle R. So angle R, so this is a 60. So if you do some matching, right, you will realize how you can find A. So you can match everything. So this one will be a 45. So you do all the matching in the angle, then you realize that you can find the value of A by doing 180 minus 60 minus 45. And of course, you got to quote the angle sum of triangle. So matching of the angle is quite easy. So let's go to the length part. You cannot match the length. Huh? So I will keep telling you in the similar triangle parts, you cannot match the length. So what are we supposed to do right now? I got the ratio. I'm going to put in my ratio carefully. So can you, like, after you write the ratio, right, replace it, replace PQ. So PQ is letter B. You also replace XY. So XY is 2.4. So just be very patient. After you write out, right, you just fill in the blank. So QR, if you look at what is your QR is a 4. Your YZ is 3.2. And PR, I got nothing. So this one nothing, right? Then XZ also nothing. If there is nothing, you can ignore the ratio. So if you write out the ratio already, you realize that you can do your cross multiplication. So if you write out your ratio already, you should get your cross multiplication. So if I compare this to congruency, I think this one is a little bit harder, but it's not very difficult. Write out the ratio, plug in, you should be able to do some cross multiplication. Okay, so this one is an example of similar triangle. And I hope you also realize I never refer to the diagram. I cannot match, I cannot do the ratio from the diagram. So I will do the ratio from the statement. So I stack up the triangle. So I stack up the triangle. Previously, we also stack up the triangle, right? But right now, when I stack up, I gave the ratio. But I can also be matching all the angle. Okay, so you need to switch your mind away from matching length. In similar figure, you're dealing with one big and one small diagram. That's why there is a certain ratio.